Hello everyone, my name is Shreyas. I am educated at an academy. You can follow me on the Learning app, as well as you can see my new set of courses on the Learning app. So this is a lesson about the Engineering Materials and Composites. So in this lesson I will be taking you around the engineering materials as well as their types, as well as the types of composites as well as their introduction, and why are these things used in our day-to-day purposes, that is in the industrial usage. So please do rate, review and share it, and please do subscribe us on our YouTube channel. Thank you. So guys, let's move along with our course Elements of Mechanical Engineering. So I have given my introduction already. This is my Unacademy user platform mentioned over here. Please do follow me over there for my new set of courses. Materials and joining process is the course on which the lessons will be there. So all my lessons will be pertaining to this topic. So the target audience for this slide will be engineering students, general audience who are interested in mechanical entities, people who are interested in machine related mechanisms, and automobile enthusiasts. So the learning outcomes of this slide will be, you guys will come to know the introduction to engineering materials, what are the classifications of these metals or materials, what are the introduction to composites, what is the classification to composites, what are polymer, metal and ceramic matrix composites, as well as the advantages and limitations of composites. So engineering materials and composites is the lesson for today. Let's start with the first set of slides. Before starting, let's have a quote, that is, the materials, they shape your idea. So depending on the materials you have, you can have a very good and creative idea. So let's start with it. What are engineering materials? Let's go on with the introduction. Engineering materials, they are actually defined as solid substances which are manufactured and used for various engineering applications. There are various metals available, and the choice of a particular material for a specific application, it actually depends on the set of properties which are possessed by the material. For example, if you take cast iron, which is a very strong material in compression, but it is very weak in tension, and it is also very brittle in nature. Steel, if you take steel as another example, it is almost equally strong in tension and compression, but it is ductile in nature, and it possesses high strength to weight ratio, and it is comparatively cheaper. So you can come to know that the various properties of these metals as follows, which is the good castability characteristics, the excellent machinability, and also the wear resistance. So these things can be got to know by the usage of engineering materials, and you can also see how these characteristics deals with the engineering materials, so that they can be used for various engineering applications and various other purposes. So let's move on. So this is what the engineering materials or the engineering metals are made of. You can see the brass over here, the bronze, the steel, the cast iron which I was talking about, copper, and cast iron, it is the most predominantly used metal in engineering purposes. So let's move on to the classifications of these metals. So classifications of these metals are divided into two types, namely the ferrous metals and the non-ferrous metals. Ferrous metals, they are divided into pig iron, wrought iron, cast iron, in which the cast iron is again divided as grey cast iron, white cast iron, malleable cast iron, spheroidal or nodular ductile cast iron, as well as chilled cast iron. There are many more for that also you can take into consideration. Steel, which is divided as carbon steels. In carbon steels you can have low, medium and high carbon steels. Then you have something called as alloy steels, tool steels, and also stainless steels. Coming to the non-ferrous materials, it is divided as copper and its alloys, whereas it will be brass and bronze. Brass is a alloy of copper and zinc, as well as bronze is a alloy of copper and tin. Then you have aluminium and its alloys, lead and its alloys, and nickel and its alloys. So what is a pig iron? Pig iron is a semi-finished ferrous metal which is produced in a blast furnace by the melting of iron ore and coke combined with a flux agent like limestone. The flux converts the impurities in the iron to a easily meltable slag. We have wrought iron. Wrought iron, it is a pure form of iron. It consists of about 99.5% of iron and a small amount of carbon content ranging from 0.05 to 0.25%, along with traces of sulfur, manganese, phosphor and silicon. Then you have the cast iron. Cast iron, it is obtained by remelting the pig iron in a cupola furnace by making certain changes to its composition while in the molten states. The principal alloying materials or elements in the cast iron are carbon and silicon. Then you have the grey cast iron, which is a simply grey iron which is produced when the molten pig iron in the mold is allowed to cool and solidify slowly. The white cast iron, it is produced by chilling or by rapidly cooling off selected areas of a casting in the mold, which prevent the graphitic carbon from precipitating out. Then you have the malleable cast iron, which is produced by annealing, which is a heat treatment process in order to transform iron carbide or cementite present in the white cast iron to graphite. Then you have the steel. The steel is an alloy of iron and carbon, with carbon content being less than 2%. In addition, various alloy elements like sulfur, phosphorus, manganese are added in small proportions to obtain the desired properties in steel. Coming to the low carbon steel, it is also called as mild steel, which is the common type of carbon steel and contains about 0.03 to 0.25% of carbon. Whereas medium carbon steels, they contain carbon in the range of 0.25 to 0.59%. And high carbon steel, they contain increased carbon content in the range of 0.6. Then you have the alloy steels. The alloy steels is used where significant amounts of alloying elements such as nickel, chromium, molybdenum, manganese are included in addition to carbon. Alloy steels are generally more responsive to heat and mechanical treatments than carbon steel. They have excellent strength, corrosion resistance, hardness and wear resistance, and it can be improved with the addition of alloying elements. Coming to the non-ferrous metals, the copper and its alloys. The copper, it is one of the most important non-ferrous metal, as you all know, and it was the first metal which was discovered by man. It is malleable, corrosion resistant, and it is a good conductor of heat and electricity. However, pure copper is very ductile and is very relatively weak. Coming to brass, brass is an alloy of copper and zinc, and the amount of zinc can be varied from 5 to 45% to create a range of brasses with unique properties. Coming to bronze, it is a broad term which is used to define an alloy of copper and elements other than zinc. The simplest bronze is copper, which is 88%, mixed with small amounts of tin, which is not more than 11%. Coming to aluminium and its alloy, aluminium is a very silverish white non-ferrous metal which is extracted from bauxite mineral. And the lead and its alloy, lead can be defined as a soft, silvery white or greyish non-ferrous metal. It is malleable, ductile, corrosion resistant and the heaviest among all the common metals, but it is a very poor conductor of electricity and it is also poisonous in nature. Coming to nickel, nickel and nickel alloys are non-ferrous metals with high strength and toughness, excellent corrosion resistance, good machining properties and superior elevated temperature properties. So you can see these are the non-ferrous metals: copper, brass, aluminium, tungsten and lead. So let's move on to composites. A composite material can be defined as a combination of two or more constituent materials which are having different physical or chemical properties and which remain separate or distinct on a microscopic or macroscopic level within a finished structure. So these are composite materials. They possess properties that are superior to those of individual materials. A simple example of a composite is the plywood, a type of man-made wood. And composite, they are made up of just two materials, that is a matrix which is a binder and a reinforcement which is a disperse phase. So these matrix, they surround and bind together a cluster of fibers, particles or fragments of a much stronger material called the reinforcement. The reinforcement, they carry the load along the length of the fiber to provide strength and stiffness to the composite, while the matrix holds the fibers together to keep them aligned in a predetermined direction. So these are actually the composites. You can see here these are various types of composites. So let's move on. The classification of composites. Composites, they are classified into two types depending on the matrix constituent and the reinforced constituent, mainly the polymer, metal and ceramic matrix, and the fiber reinforced, particle reinforced and laminated reinforced matrix composites. So what is a polymer matrix composite? They are classified as polymer matrix composite when the matrix is made from a polymer resin material. The reinforcement material is usually in the form of fibers like glass, aramid, carbon, graphite and boron. There are two kinds of polymers, namely thermosets and thermoplastics, which are in use for the matrix materials. The polymers, they make ideal materials as they are light in weight, abrasion and are chemically resistant. They can be processed easily and they possess other desirable mechanical properties such as high compression strength also. However, they possess low tensile strength and low impact strength, which restrict them for low strength applications. So let's move on. This is actually a type of polymer matrix composites. So metal matrix composites, they are classified as metal matrix composite when the matrix is made from a metal or alloy. The reinforcement material is usually in the form of fiber or small sized particles made from ceramic or metallic materials. Most metals and alloys can be used as matrices. However, only light metals are responsive with their low density proving an advantage. The titanium, aluminium and magnesium, they are most popularly used matrix metals and particularly used for aircraft applications. The common characteristics include high strength, fracture toughness, low coefficient of thermal expansion, and they are used in the manufacturing of automotive parts. So you can see here the metallic matrix composites. So you can see here these are used as per gauge. Moving on to the ceramic matrix composites, they are classified as ceramic matrix composite because the matrix is made up of a ceramic material like silicon carbide, aluminum oxide or zirconium oxide. The reinforcement material is usually in the form of a fiber and is also made from a ceramic material like silicon carbide, aluminum oxide or mullite. Their characteristics include high melting points, good corrosion resistance and stability at elevated temperatures. They are also used in automotive industry for the manufacturing of various components. So you can see here these are types of ceramic composites. So this is how the ceramic composites, you can see here, they provide the outer shell for the automotive parts. And this is actually an inorganic polymer which is used in the ceramic composites. So let's move on to fiber reinforced composites. They are classified as fiber reinforced because the reinforcement added is in the form of fibers. A fiber is a slender, elongated thread-like structure which is characterized by length and diameter thickness. The most common types of fibers used are glass fibers, carbon fibers and aramid fibers. Their fibers are generally circular in cross section, but it can also be in the form of tubular, rectangular or hexagonal. The diameters of these fibers, they range from 0.0001 inch to 0.005 inch. Fiber reinforcement composites, they can be further devised based on discontinuous and continuous type. Continuous fiber reinforced composites, they contain fiber reinforcements having lengths much greater than their cross-sectional dimensions. And discontinuous fibers, or short fiber composites, they have properties which vary with the fiber length. And discontinuous fibers, they are the most practical composites that are being developed for engineering applications. So you can see here these are the fiber reinforced composites, and you can see various here, the continuous fiber composites, discontinuous fibers, the bidirectional and the woven fiber reinforced composites. Moving on to the particulate composites. In particulate composites, the reinforcement, it consists of small metallic called ceramic particles embedded in a matrix. They are in flakes or powder form. They have the diameter of 0.25 micron. They have improved strength, increased operating temperature, oxidation resistance, and they are used for the making of dashboards, brakes and pistons. So these are the types of particulate matrices. You can see the micron structures of them. And laminated composites, they are made up of layer of materials. Plywood is a main example for that. They have grains fluctuated at right angles. They are very hard to bend at right angles because of this phenomenon. They make the usage of a fabric material, and they are used for making of plywoods, wear pads and wear strips. These are composite materials, the laminated composite materials. So what are the advantages of these composites? They have high strength, high resistance, they are durable, they have excellent structural damping features, they are dimensionally stable, reliable, they have improved torsional stiffness and improved friction and wear properties. The limitations are they are high cost, they have weak transverse properties, they are difficult to reuse, they have no combination of strength.